Hey guys, we're going to talk about finding the six trigonometric functions from a coordinate. So the problem we're going to work through, it says let 3, -7 be a point on the terminal side of an angle theta in standard position. Evaluate the six trigonometric functions of theta. Leave your answer in simplified radical form. So we've talked about angles in standard position and terminal sides. So first thing I'm going to do is go to the xy coordinate plane and I'm going to figure out where in the world is this coordinate at. So 3, -7 means I'm going to move over on the x-axis 3, 3, and then down 7, 1, 2, 3, 4, 5, 6, 7. So we're talking down here. So if we want an angle in standard position, and that's the terminal side, I know the first part of this angle, the first ray is up here, the second ray is going to be there, with this angle being right here. Now, in order to do the trigonometric functions and all that, we're talking about triangles. So we need to find where in the world is the triangle that relates and allows us to find all these angles. So what you're going to do is you're going to take that point that is on the terminal side and draw a segment or a line from that point to the x-axis. So if we go this way, what I form here is a triangle with this being a side, this being a side, and that's my hypotenuse. So I'm going to rewrite it over here so it's a little bit easier to see, because I'm dealing with a triangle somewhat like this with theta located here. So now that I know what triangle I'm dealing with, in order to do the trig functions, I probably need to know what are all the side lengths. So we did know this point was 3, -7. So in order to graph it, I moved over 3 to the right 3. So I know this distance is 3. And then I moved down 7. So I know this distance and this side is -7. So in order to do the trig functions, I need to know all three sides of this triangle. So I need to solve for this missing side. So a common theme with the trig functions is using the Pythagorean theorem, which is a squared plus b squared equals c squared, with c being my missing side because that's the hypotenuse. So I'm going to plug in the pieces I know, and I'm going to solve for the missing side c. So we're going to have 3 squared plus parentheses -7 squared equals c squared. So moving through this, I would have 9 plus 49 equals c squared, which is 58 equals c squared. In order to solve for c, you're going to have to take the square root of both sides, so we get c equals the square root of 58. So my missing side is the square root of 58. You would want to see if we could simplify this square root if we can. The square root of 58 does not break down. There is no perfect squares like 4, 9, 16, or 25, 36 that divide into 58. So nothing we can do with that. So what I'm going to do is I'm going to go through and answer the 6 trig functions that pertain to this angle theta. So what I'm going to do is I'm going to set them all up. So we're going to have sine of theta, cosine of theta, tangent of theta, and then I'm going to have cosecant of theta, secant of theta, and cotangent of theta. So I just need to fill these all in. I'm going to fill them all in first, and then I'll worry about simplifying and reducing all that, rationalizing at the very end. So if we think of SOHCAHTOA, so if I want sine, I want opposite, which is opposite of theta would be -7, divided by the hypotenuse. So we're going to have -7 over the square root of 58. And I'll come back to simplifying and rationalizing here shortly. Then we have cosine of theta. So cosine is adjacent, which would be 3 divided by the hypotenuse. So 3 over the square root of 58. And then finally, tangent, TOA, opposite over adjacent. So the opposite side is -7, the adjacent is 3. So I'm going to have -7 over 3. And in one of my earlier videos talking about trig, we talk about the link between sine, cosine, and tangent, cosecant, secant, cotangent. The link is straight across. Sine and cosecant are together, cosine and secant are together, tangent and cotangent are together. In order to find these other three trig functions, all you're going to do is take the reciprocal of these three. Now, reciprocal, what that means for a math student that doesn't know means we're going to take this fraction and we're going to flip it. So instead, I'm going to end up with the square root of 58 divided by negative 7. I'm going to have the square root of 58 divided by 3. And I'm going to have a negative 3/7. So those are all 6 of my trig functions, but before I say I'm done, I want to make sure, is there any reducing, rationalizing? Check to see if any of that exists. So things I see is we have some square roots here. We're allowed to have a square root in the numerator at the top, but we cannot have them in the denominator. So we have to do something called rationalize the denominator. In order to do that, we're going to multiply this by the square root of 58 on top and bottom. We have to do it on this one as well. Multiply the top and bottom by that square root of 58. When we do that, up top we have a number outside of a square root, number on the inside, so rational and irrational. So we're going to have negative 7 square root of 58. And on bottom, we take square root of 58 times square root of 58. That simplifies to just 58. So sine of theta would be negative 7 square root of 58 divided by 58. This bottom one here, I have 3 times the square root of 58, so 3 times square root of 58. And the denominator, square root of 58 times square root of 58 is, almost wrote a square root there, 58. So there's all 6 of my trig functions. I don't see anything else that could be simplified. Like if this was like 9 over 3, you could do something with that, 3 over 9. You could reduce that fraction, but there was nothing else we could do. So that is my 6 trig functions. And that was finding the 6 trig functions from a coordinate.